In this video, I'm going to be going over cardiac myocyte action potential. There are going to be three ions that are going to be playing a role in cardiac myocyte action potential. It's going to be the sodium ion, potassium, and the calcium ion. A voltmeter is going to be used to measure the electrical difference between the interstitium and the cytosol, and the resulting electrical difference is the voltage. And a millivolt is going to be measuring the voltage, which is going to be on our y-axis, and time is going to be on the x-axis. When the electrical signal reaches the cardiac myocyte, the resulting voltage change is going to be sensed by voltage-sensitive sodium channels, which are going to open. Sodium is then going to flow into the cell. Sodium is a positive ion, has a positive charge. As a result, that is going to be depolarizing our cell, and that is known as the phase 0, which is the upstroke phase. Shortly after, the voltage change is going to be sensed by voltage sensitive potassium channels, which are then going to open, and then potassium is going to start flowing out of the cell, and it is going to briefly repolarize the cell, and that is going to be phase 1, also known as initial repolarization phase. Shortly after potassium channels open, calcium channels are then going to open, and calcium is going to flow into the cell. That is known as the plateau phase. It is known as the plateau phase because both calcium and potassium channels are going to be open. So positive potassium ions are going to be flowing out of the cell, and positive calcium ions are going to be flowing into the cell. As a result, it is going to be creating this plateau phase. In phase 3, calcium channels are going to then close, and only potassium channels are going to be open, and potassium is going to be leaving the cell in large numbers, and that is going to repolarize the cardiac myocyte. This is known as the repolarization phase. And in phase 4, eventually the voltage is going to return to normal. Potassium channels are normally more permeable than other channels at rest, and this is going to be responsible for the negative resting membrane potential.